Okay, I think we can start. Thank you everyone again for joining, and especially thank you to those who've been with us for the past week. So today we have our last, but not least, of course, webinar. And just to remind you that QA and chat we have as usual. So chat is for chatting, obviously. And if you have any questions which you want to ask Andre, please write them down in Q&A, and we'll look through them at the end of the webinar. And as well, please don't forget to write down the last word, which Andre will have on his last slide, and send your sentence to us to employer branding mailbox afterwards to receive your gift. So today we have Andre Podnozov with us, who is IoT Solutions Architect in Seattle, and I would like to pass the word to him. Thank you.
Thank you. Yes, hello. I'm Andre, and today we're talking about this very interesting topic of digital twins. So let me start with an introduction. I'm an IoT architect at Luxoft, based in Seattle area, and I work as a part of the global IoT practice at Luxoft and DXC, since we're now Luxoft is a DXC technology company. And previously I worked at both major cloud providers and other large companies like Intel or I've done over a decade of consulting and anyway, let me first thank the Luxoft employee branding department for organizing this series of webinars, and because well, okay, I can't, this cat is just too cute. I just keep wondering why I didn't get this cat as a part of my employment contract. I should have negotiated harder. Anyway, now that you are gonna see the last 6 webinar of this series, this hopefully give you everybody a good idea that Luxoft is a very interesting place to work if you're going to consider a career change. As far as the agenda of today's talk is, we'll start with first, we'll start with understanding what digital twins are, and we'll look at their historical perspective, where it came from, and we'll examine where we are today with digital twins and see what is their significance going forward. Because I think this is one very important service and not service, but technology, and I will try to prove it to you in this talk today. And we'll wrap up with a Q&A, depending on how much time we have. So what is digital twins? This is the first question we need to ask and try to answer. The digital twins generate a lot of interest these days, and judging by a very good turnout on our call today, this is also true for our audience, but the question remains, because I bet some people would find it difficult to explain what it is. And even when people talk about digital twins, we often find that people talking about different things. And that's why I'm calling it the Babylonian challenges, trying to find a common language when talking about digital twins. So is it like, what are we talking about? Is it about 3D models? Is it about building construction? Is it about augmented reality? We have examples of all of these elements in this picture. Is it, or you would hear terms like virtual twins. Is it the same or different? How about device twins? So looks like we have a lot of work ahead of us in trying to understand it in this short hour. So let me start with this definition that I borrowed from Microsoft Azure. This is how they talk about their digital twins service. They say that digital twin is live replica of any physical environment, processes, people, systems. It tracks the past and predicts the future. So this is such a short definition, but it has a lot of meaning to it. Let's try to unpack it a little bit. So first of all, digital twins. From this definition, we can see that digital twins not only applies to physical objects, but also to abstract concepts like, processes or systems, right? And it is a live replica. What does it mean? It means that it reflects current state of the entity based on sensor data from IoT. And it's more than just a simple kind of indicator of current state, because digital twin encapsulates the deep understanding of this entity, and it can even predict the future state based on the current data. So this predictive capability is very important here. It's a sort of a signature trait of digital twins that sets them apart from earlier generations of online monitoring technologies. And in fact, at that point, it doesn't even have to be online, right? We can think about autonomous car that is explicitly designed to operate correctly in completely disconnected scenario based on the models of intelligent behavior incorporated into the car itself, right? Let's see. Here's one more definition that comes from Wikipedia. Digital twins integrate IoT, AI, ML, analytics with spatial graphs to create living digital simulation models. So, okay, let's parse this one. First of all, we already see some parallels in this definition with the previous slide, such as IoT, right? Because we already mentioned the sensor data that comes from IoT, and the word simulation here is a synonym for predicting the future from the previous definition. But this definition goes even further to give us a hint that these special psychic talents of digital twins, predicting the future, they are based on AI and ML models. So together, these two definitions also help us establish this three-sided relationship between digital twins, IoT, and AI ML. So let's remember this. We'll get back to this thought later. On this slide, I would like to, I gathered a few kind of representative pictures to illustrate how digital twins can manifest in different scenarios. And one thing we can notice right away is that, see how, look at these, right? And these wireframes, right? Or what are they? Polygon meshes, right? 3D representations. And so here as well, this is what people think about, first of all, when they hear about digital twin. It's got to be this precise 3D representation, right? This is, it doesn't have to be like this, right? Because depending on the domain and the scenario, the exact geometry and exact look and feel may or may not matter. So first, let's look at an example where it matters. Like in this example where we have a digital twin of electric motor. The electric motor is modeled using physics simulations, and those physics simulations, they can be calculated rather precisely from the geometry of the motor. Or let's look at this example. This is augmented reality case. See the glasses, and this is a maintenance worker who is maybe fixing a machine that has some red alerts, right? So in this case, it is important to have a correct 3D representation of this complex machinery in order to put these sensor data into the correct context. But then let's look at this other example where, so okay, this looks like a smart city scenario, and so it has precise geometric shapes of buildings and lampposts. But if you think about it, if your smart city scenario need to enable, for example, make sure that people can quickly find the parking spot, then the exact shape of the lamppost doesn't really matter, right? And the, okay, so human body. This one example I wanted to get a little deeper into. This is a smart spaces scenario where, let's say it's an office building or maybe a co-working space where that has some conference rooms. Some of them are free, marked in green. Here, some occupied in red, or maybe red is maybe some alarm like AC is not working, so better not use that room. And then some rooms may be partially occupied and whatnot. So this scenario does rely on the 3D model of the floor plan, or a 2D model, or both. But the main point of this scenario may not be about the layout, but rather it may be about, let's say, maximizing utilization of the space, for example. This is one of the important KPIs of the co-working facilities. They want to make sure that their spaces are used by paying customers as much as possible, and yet at the same time they don't want to kind of turn away customers by being always fully booked, because that creates unfavorable experience. And so they need the predictive capabilities that the digital twin provides in this case, in order to predict their the upcoming demand. And so that's what one of the floors of the building may do with the installed smart spaces sensors, like occupancy sensors and temperature and humidity sensors. But then other floors of this building may use these information in different ways. So for example, other floors of this multi high-rise building, maybe let's say if it's not a co-working space, just a office space, they want to optimize the electricity usage. So they use the same sensors but in a different digital twin context. So therefore, the nature of the digital twin depends on the context of how it's used and what domain it's used in. And it goes up, like the different floors comprise together into the whole smart building at that point. And then at a whole building level, you may be solving yet another set of important objectives, such as safety in emergency scenarios, for example, and so on. So you see how in this case, it's more than just sensors. It's more than just IoT, but rather the digital twins, they work with the domain from the business goals perspective. So very good. I think I'm already overdue on this slide. Let me move to the next slide. Origins. Who is this person? This person is Dr. Michael Greaves. He is he is the kind of the inventor of the concept of digital twins, and he focuses in the manufacturing domain, among other things, and he wrote a lot of articles and white papers on this topic, and he gives talks. This is a slide from one of his papers on digital twins in manufacturing. But the term itself, the term digital twins was kind of floating in the air even before the research by Dr. Greaves. And in fact, we know that going further back into the history, NASA was already employing twinning techniques during their Apollo mission program back in the 60s. They used, so this is a picture of their simulation center for the Apollo mission. And there are like 15 different simulators that the center had, and they were used for for training the astronauts and the the personnel in the flight control center, and for testing different procedures for the flight. And these simulations were highly precise simulations that were computer-driven simulations that were operated by these, you see these mainframe racks, they had the 8 computers there on site that were supporting all these simulations here. And the reason that people say that NASA is kind of the pioneer of digital twins is because of this infamous Apollo 13 accident and use of these simulators in conjunction with the live data about the state of the ship, spaceship, help them come out with the right solution and help them bring the astronauts safely back to Earth. Even though they didn't have the IoT back in the days, the communication was done. They still had like a state-of-the-art telemetry even then. So I think this is a very good example of an early digital twins. And so let's see. Now, if we move to this century, here's how we can talk about digital twins. We can use these Gartner hype cycle curve. I'm sure people are familiar. For those who are not familiar, let me give like a brief overview of what this is. This curve shows the level of excitement about particular technologies and how they progress with time. So it starts with the technologies being completely unknown, and then as time moves on this horizontal axis, technologies become more known, and the level of expectations on this vertical axis, it increases. I mean, what expectation? Expectation of their usefulness, and it culminates here on the top of the curve. This is the peak of inflated expectations. They're inflated because at this point, the expectations are obviously out of touch with reality. But people or companies who can foresee the potential benefits of the particular technology, they already can start taking advantage of these new technologies. But then as people start to actually try to apply these technologies, they realize that the expectations were kind of overinflated and reality sinks in. So kind of the hype dies down. This is the phase, this lowest phase is called the trough of disillusionment. It's like people are not disappointed per se, but there's definitely, you can see there's several times of less excitement here, right? But then this is actually a very important part here, because from this point on, there comes a stage of actual useful of productive usage of these technologies. And so this is the chart from 2015, Emerging Technologies Hype Cycle. So let's look at that. Internet of Things, right on the top of the chart, right? Highest expectations. And so how did it get to this place? We can look. This is the history of how from beginning of that decade through the first half of the decade, how Internet of Things was rising to the top. 2011 is the first year when Gartner started tracking Internet of Things on the hype cycle curve. And it started here from the middle, and it was, in 2012, made some progress, and then more progress, and then landed on the top in 2014, and it stayed there essentially for the next year, to the point that in the future years, Gartner just gave up and said, we're not going to even draw it anymore. instead, because it was so popular that they made its own hype cycle curve. This chart is a 2016 chart of hype cycle for Internet of Things specifically. And this is the first year where we see digital twins appearing on the hype cycle. And it starts its rise to the top. From 2016 to 2017, a good jump to the middle of the curve. 2018 gets almost to the top. 2019 stays at the top. 2020 results are not with us yet, but it essentially mirrors the rise of IoT itself, but with a few years lag, right? And here's another way to look at this progression. It's called the technology adoption lifecycle. This gap here is called a chasm. Chasm. It's something that separates two sides. This side of early adopters and enthusiasts, technology enthusiasts, on the left here, and on the right is the mainstream users and adopters. And this gap, this chasm, it actually matches the trough of disillusionment on the hype cycle curve, because the kind of before this point, this part is early adopters. After this point, the phase of productive usage, that's the mainstream adoption already. And in fact, here we can see that Internet of Things on the 2019 curve, Internet of Things is like going for the trough, actually, which on one hand you can think that, oh, it's maybe a bad sign, but on the other hand, it's actually, it's very good looking forward. It means that Internet of Things itself is right on the edge, or maybe even transitioning through this gap, and so soon we will meet it on the other side, and from that point on it's going to be mainstream adoption. But tech visionaries, definitely the big players in the tech industry, they've been already working with digital twins, even starting with for the last 5 years. As soon as it appeared on the hype cycle, that already represented the early efforts by companies like PTC and GE, and by today, other big players already joined, like Azure with their digital twin service. AWS have Sumerian that can be used for AR VR application, and IBM Maximo. Siemens has a digital twin effort. Google has digital twins. I would like to play a video for you. So here, this is a video of how Google talk about their digital twins.
Carlis, what are you doing?
I'm trying to figure out how I can automate all my lamps and devices without manually configuring each one.
Oh, I have a solution for you. Just build some digital twins.
What's that?
A digital twin is like a digital version of your physical devices. Let me show you how to build one on Google Cloud Platform.
That sounds awesome. Let's get started.
The solution we built today looks like this. The blue boxes are managed products which we can use directly. The only places where we need to write our custom code are the two yellow boxes, which are cloud functions that links IoT Core and pops up with Firestore.
So all the infrastructure will be managed, and we are just writing some custom glue to fit the pieces together.
Yes, let me show you the code. For this project.
Okay, I'm going to stop this. This is obviously not a serious thing, right? Because the three-box architecture is this is just another example of how of that Babylonian challenge that I was talking, because what they're describing is more of a device twin rather than digital twin, because let's look at the actual architecture of what's involved in the real digital twin scenario. And you see there's so much more complexity there. This is a architectural diagram from Azure Digital Twin Service. And the devices part here in green is only a small subset of the whole picture. And the rest of this blue components represent all the intricacies of the specific domain and all the complexity that it every domain brings with it. So this is for your developer folks who may want to start looking into a digital twins. By the way, next week, Microsoft Build event is going to start. It's a free event this year, and I'm sure Microsoft is gonna come out with a lot of stuff, a lot of new stuff about digital twins, because up till now, it's the digital twin service has been in preview. So, and they usually update a lot of stuff during the build, and it's overdue for another update. So look forward to a lot more digital twins news from there. So I was going to I was thinking to do a demo, but it's in the preview is right now is in private. It's locked, and anyway, it's not very user friendly. There are demos on the internet. Look for IoT show with Olivier. He has a number of videos about digital twins. But for now, let's talk about this next the next slide. This next slide represents now that we covered the past and the present, this one represents the future portion of it. And so digital twins and the next human civilization. That sounds grandiose, I know. So what are we really talking about? Let's see. We're talking about the next era of human civilization that will be built on the benefits of AI, where AI is a helpful friend rather than a competitor against humans. And this is not some kind of science fiction. The threat of losing jobs to robots is here today, and this tension will only be increasing in the coming years as the AI progress accelerates at ever-increasing pace. There's a great book on this topic by Kai-Fu Lee called AI Superpowers, Silicon Valley and China, and he gives some very interesting numbers of, for example, of the percentage of jobs that will be threatened in the next few years by AI and robotics. And in some studies, these are staggering numbers, like upwards of a 50%. So I mean, I'm not making this up, right? And the funny thing is on one hand, humans are wary of AI and robots, but on the other hand, humans desperately need AI help to solve some of the most pressing problems of our civilization, like diseases and climate change, food and shelter shortage, healthcare and elderly care, poverty, inequality, and so on. So this is the dilemma we need to solve. How to turn AI from a foe to a friend, and do it in a way that serves the needs of all members of human society. This is where digital twins can play a very important role. Let me explain. Remember how in the beginning we talked about the symbiotic nature of AI, IoT, and digital twins. Because AI needs IoT to feed it the massive amounts of data, because that's when AI really shines. The more data you give it, the better quality of the intelligent insight you're going to get out of it, right? And in turn, IoT needs AI to give it the level of smarts and intelligence that is required to operate in the physical world, because the stakes are high in the physical world, like, you know, physical harm to people and damage and whatnot. And so digital twins, what's the place of digital twins in this picture? Digital twins acts as the delivery vehicle of AI benefits to the users. So essentially, digital twins is the productized form of AI that is built into these smart connected products and services that are based on IoT and AI. And so already today, you can see the digital twin marketplaces starting to appear, such as IBM Digital Twin Exchange, where people can buy and sell these smart digital twin modules, and similar things exist on other platforms. So this is how digital twins can help us bring the benefits of AI into every user's hands and help them take advantage of IoT for their benefit, right? So for the summary slide, I would like to leave you with 3 takeaways. That digital twin is a replica of real-world entity powered by IoT sensor data and with behaviors that are based on AI and ML models. That digital twin is more than just 3D model. It's more than just blueprints of a building. Digital twins solve the needs of the specific business domain. And ultimately, that digital twin enables a future that is enriched by AI. And now we open to the Q&A, and please notice the last 6th word of our webinar series to complete the puzzle. How can we answer some questions? Okay, I guess I'll look at the Q&As.
Yeah, there are 2 questions at the moment in Q&A.
Do you agree that digital twins could be segregated in two parts or two halves, ML-based and equation-based? For example, if we know equations of mathematical physics describing the object, we do not need any ML models. So this is a great question. In today's level of sophistication, the digital twin will be powered by multiple models, because yes, in the past we have already mastered building models based on multiphysics and other just equations that can be calculated. But now that this kind of low-hanging fruit, if you will, is consumed already, we are now moving into more complex scenarios that for which we may not even have equations. And so it's a combination of the precise sciences and the statistical sciences that gives us the most powerful combination that is not achieved by any other means. And that's the kind of forward-looking benefits for the civilization that we're talking about. Okay. Consider educational domain like our Lux Talent. A company has a digital twin of its educational department. They talk to each other, establishing talent needs and educational offerings. On the other hand, an employee and his digital twin also talk. And the company digital twin talks to employees digital twin, preparing company for future challenges. Is Luxoft working on such project for internal use for later sales? So very interesting angle. So in this scenario, we can talk about a digital twin of an organization, or maybe of a digital twin of educational process. And also we can talk about digital twin of employee, and how they interact in a complex relationship that is very dynamic. So this this example is a great illustration how, if you think back to that Google, just put together 3 blue boxes and you have digital twin, right? It's way more complicated than that. To answer your question, is Luxoft working on such project? I'm not aware of one, but if the educational department wants to discuss that, please reach out to yes, please reach out to us and we can discuss that. I think we will be able to provide contact. Julia can provide a contact. Okay, could you explain about DTP and DTI, prototype and instance ones? Don't worry about this. It's very academic. Yeah. For our purposes, it's a lot more interesting to get like the practical knowledge and experience with digital twins, because this year is the year of digital twins. We already saw that in the beginning of this year. The interest in digital twins exploded just before the the unfortunate situation with the coronavirus. So I expect to see a lot of meaningful work coming on the horizon in digital twins. So it's very interesting to get practical skills in digital twins rather than this theoretical knowledge. Another one, consider 3D model of RAMI 4 if you know. I don't know, I'll skip this one. Okay, let's see. Do we have anything in the chat?
In the chat, the majority about the sentence. So guys, any other questions maybe you want to ask? Please write them in Q&A if we missed your question. Okay, so I guess there are none. Oh no, there is a question.
What do you think about relationship among digital twins and cyber physical systems? What event is scheduled by Microsoft next year? Oh, okay, lots of questions. Very good. Digital twins and cyber physical systems. So cyber physical systems, are we talking about IoT? I guess, maybe? Cyber physical systems. So I think the answer to this question is how we already discussed about the three-way relationship between digital twins, AI, and IoT. IoT is IoT gives access to the physical domain. IoT provides AI with access to the physical domain. That's how AI can operate on the real world through IoT. And the digital twin sits kind of between AI and IoT, or rather it kind of packages AI into the IoT. So that's the kind of the relationship between them, if I understand the question correctly.
He has some corrections here. He's talking about embedded systems. Wrote it below.
In industrial context, like embedded systems.
Mm-hmm.
Yeah. Well. So industrial context was the first that's where the first success stories of IoT were. And I think I expect that industrial applications we will see the first successes of the digital twins there as well. In fact, the examples by, the study by Dr. Greaves already, because he focused in the manufacturing domain, that kind of underscores this. And even Luxoft has done work in the manufacturing process on simulations and kind of the early digital twins and manufacturing process in the early 2000s. So so yes, I expect to see a lot of focus on digital twins in the industrial applications. Let's see. Consider simulating of a product and end-to-end engineering. Now, do you think which company has best integrator enterprise design of digital twin thing? I think Siemens. Siemens is very strong company just because of their end-to-end capabilities, exactly like you mentioned, right? And yet, I would like to note that even such a giant companies like Siemens have to partner with cloud providers. Remember that Siemens partnered with Microsoft on integrating their MindSphere platform with Azure IoT, for example, right? Because this is like a classical example of how the field of IoT is, you cannot do it without collaboration, because IoT and AI solutions, they're just too complex for any one company to master. And that's why you see examples of companies like Mercedes and BMW and Volkswagen, top world car manufacturers, going partnering with cloud providers, because even though they know everything about cars, they don't know enough about cloud, and vice versa. Microsoft may know everything about cloud, but they don't know enough about cars in order to offer the right solution. That's why they need to partner. And with Siemens, I think it will be the same story. having to partner. Companies that try to go this themselves without opening to collaboration will experience difficult time. What event is scheduled by Microsoft next week? It's a Microsoft Build. It's on the 19th and the 20th and 21st, Tuesday, Wednesday, Thursday. Just search for Microsoft Build 2020 and you'll find it. As I understand, we could not implement digital twin without AI. So back in the day, when we didn't have AI, people implemented digital twin without AI. But now that we have AI, of course, AI brings such a compelling benefits that yes, the full power of digital twin is realized by combining all modeling and simulation methods, including AI and physics and all of them together. Digital twins may refer only to two entities, groups of twins, or can be more than two. Let me see if I understand the question. Two entities, groups, or twins. I see. So if you remember the example of a smart building, the relationship is more complicated. It's more like a many-to-many relationship, because you have a digital twin of a smart building, which is an entity in the virtual domain. And in the physical domain, what you have is a many number of sensors that are in this environment, and including other actors like people who are also in this environment. They interact with the environment, they affect the environment, they have specific goals that the environment need to serve, like comforts, like, you know, putting the right temperature and lighting conditions. And so relationship is not a one-to-one, that's for sure. And when we talked about spatial graph, relationship is not even hierarchical. It's truly a graph where, imagine you have people in the building and people are moving from floor to floor, right? So how you could have assigned people to individual cubicles, but that assignment can change dynamically in time. Could you please determine the place of ML and CAD designs and IIoT and interaction together in DT process clearly? Okay, so ML is, you know, we use it. We use the word ML with a slash, AI/ML. So this is, we know that this is kind of the centerpiece of the digital twin value proposition going forward, right? CAD and BIM and 3D designs, these visual designs, they are important only in certain scenarios where it is essential to have the actual precise geometries, and they may not be important in other scenarios. Industrial IoT, how does this apply to industrial IoT? Many IoT scenarios, such as predictive maintenance and asset utilization, have a very direct application in industrial IoT and bring direct benefits in industrial IoT. So I think that's the best I can describe this. Can digital twin be considered as pillar of Industrial 4.0, or what importance does digital twin bring in Industrial 4.0? So Industry 4.0 is it's the best, is the vertical that is the best prepared for using things like IoT and digital twins. Why? Because they've been doing this for decades already, right? Think about all the industrial protocols. What did we have before IoT? M2M and, you know, all your SCADA and automation and whatnot, right? So they have a lot of great foundation. That's why industrial IoT has seen the first successes in IoT, and by the same token, they will probably be able to realize the benefits of digital twins the first as well. Because look, in industrial scenarios, it only takes like a couple % of benefits in order to translate into millions of dollars of saving, right? But remember how we talked on the last slide about this kind of new next wave of human civilization. The benefits of IoT and digital twins need to come to the end users. This is where the ultimate goal is, because if you keep the benefits to the corporations, this creates even more danger of tension, because people will be unhappy that the companies are keeping all the benefits of AI, very powerful benefits. Companies keeping the benefits to themselves, right? So, and consumer segment has been the most difficult so far. And it's, well, at least in the Western world, because in China, the situation is different, of course. So industrial IoT is a very important short horizon, but in the long horizon, consumer segment is probably start to take over. One of the twins' name is IoT and the other one is AI, as far as I understood. So I suppose the technology might be used almost in every area where we need to use data from physical sensors. So that's not quite correct. IoT and AI are just different kind of aspects of digital twin, because digital twin needs to use IoT in order to keep its replica state up to date. And it needs to use AI and ML in order to have this intelligent predictive behavior. So that's how they work together, right? But yes, going forward, there will be lots of place for IoT and AI in all aspects of our lives. And in fact, digital twins will apply even in those places where you don't have physical sensors, like if you're talking about digital twin of a government or some other abstract entities, digital twin of planet ecosystem, whatever. Okay, can services like Alexa and Google Home be considered examples of usage of digital twins? No. Because digital twin need to fulfill a certain business objective in the domain, and the Alexa and Google Home, they belong in a consumer space, and consumer space, like we just discussed, has been kind of the most struggling segment of IoT. So therefore, for now, Alexa and Google Home would be a very big stretch to call them digital twins. Is it safe to assume that digital twins has come to stay post COVID-19? Has come to stay post. So, like I mentioned, there was already kind of an explosion of interest in digital twins starting from even like end of last year, we started to see digital twin conferences getting scheduled in all parts of the world. And COVID kind of put the brakes on this a little bit, but I think it's even, especially in difficult times like this, companies need every bit of help to, to stay productive or even stay alive. And so they need these intelligence from AI and IoT and digital twins. So I think it will be a great boost for these technologies in helping to solve the current challenges. What is the implication of effect on our jobs? So different categories of jobs are affected in different way. And interestingly, the most kind of highly skilled jobs are affected in the worst way. For example, think about like a doctor, medical doctor, or a radiologist who look at your X-ray photo and makes a diagnosis. Today already, AI can make the diagnosis a lot better than a radiologist doctor. So those highly skilled professions are already threatened today. And the other kinds of like thing, I don't know, handyman or a plumber, they are not as affected because robotic technology have not reached the level of sophistication that's required to, like the fine motor skills and dexterity of human fingers for now are out of reach of robot capabilities, but it's only a matter of time until it catches up, so nobody will be protected. There are certain categories of essential human activities that no robots can do, like, I don't know, care for how people care for each other, about each other, love and compassion. Making babies, essential human activity. No robot can replace humans, right? But this brings up like a very big philosophical question. How is human worth valued? Because right now, human worth is valued at certain dollars an hour, and this is not the economic equivalent. Is not how it will be valued in the new civilization, because robots will be able to bring a lot more economic product at a fraction of the cost, and yet they will not be able to do these other things. And so this will cause a rethinking of machines rule humans. That's right.
So guys, we just passed our time and ran out of time. So I don't think there are any questions right anymore. So thank you everyone. Thank you, Andrew, for your presentation. It was great. So just wanted to let everyone know that we will put all those webinars on YouTube, and you will be able to access them next week. We'll send email to everyone as well with the links and a short survey there where we'll ask how you enjoyed today's presentations and this week and in general marathon, and what you have ideas how we can improve it in the future. Please don't forget to send the sentence to employer branding email. It's employer_branding at luxoft.com. So please send it to us and we'll share gifts with you. And thanks everyone again who especially participated for the whole week. Please answer some short questions I have here on the screen for you. And yeah, thanks again and have a great weekend.
Thank you. Bye.